Welcome back, Algebra 1. We're going to go over some notation, and we are going to focus on recursive sequences. Today we're going to focus on arithmetic sequences, and then I'll do another video for geometric sequences. So n represents the term number. So when n is 1, that's the first term in the sequence in the list. When n is 2, that's the second term, etc. So f of 1 means first term. F of n is nth term, so any number that you put in there, so 100 is the 100th term, f of 100. If f of n is the nth term, f of n minus 1 we call the previous term, it's the one before. So for example, if we asked for f of 6, the previous term would be f of 5. It's one less than the number n. D is our common difference. And that's used for arithmetic sequences. And then the ratio is our common ratio for geometric sequences. That's what R represents. And we will get to that in our next video. So to go over this, f of n is our nth term. Now, I know that the f of n plus 1 is the one after, so it's the next term. So it's first term after, or next. So f of n minus 1 is the first term before, or the previous. So then f of n plus 2 is the second term after. Whatever term you're discussing. F of n minus 2 is the second term before. That's how the notation works. And we'll get used to this throughout. So when we write a recursive rule, the word recursive means we need to know the one before. So this is our formula, and I'm going to go ahead and write what this means. So this part right here, f of n is the nth term equals f of n minus 1, the previous term, plus d. D is the common difference. So you take that each term and you add the common difference to it, or subtract, you can always add a negative, to get the next term. And so then we have up here, when f of 1 equals some number. So we have to know where to start. So this right here is given the first term. So let's take a look at some examples. So for example 1, we have 2, 13, 24, 35, and 46. So to go from one to the next, we know that to go from here to here, we add 11 every single time. Therefore, our common difference is 11. And then right here, 2 is our first term. So to write a recursive rule, we need to know the one before. So I'm going to write this to remind us. The nth term equals the previous term plus the common difference given the first term. So if we write that in notation, the nth term is f of n equals the previous term is f of n minus 1, that's never going to change, plus the common difference. Our common difference, d, is 11. When, I have to know where to start, when the first term, f of 1, equals 2. This is our recursive rule for that sequence. So let's take a look at example 2. So if we look at this, our first term we know is 5. To go from 5 to 7 to 9 to 11 to 13 to 15, we know we have to add 2 every time. So that is our common difference. So for our recursive rule, I have any term f of n equals the previous term f of n minus 1 plus 2 when the first term equals 5. Taking a look at example 3, n represents the table, remember? So our first, term number, so our first term is 29. Our second term is 24. Our third term is 19. That's how we read that. So if we look at this, our first term we know is 29. And then we're subtracting 5 every single time. Therefore, our common difference is -5. So when we write our equation, our recursive rule, any term equals the previous term minus 5, when we have to know where we start, the first term is 29. And that's our recursive rule. So once again, I have my first term as 44. And then I need to add 11 every single time. And it's an arithmetic sequence because we're adding. And so we know that because we're adding 11, our common difference is 11. So we have f of n equals f of n minus 1 plus 11 when our first term equals 44. That's where we start. The last piece I want to go over is that to find if we're given the formula instead, find the first 5 terms of the arithmetic sequence given each recursive rule. So I know from looking at this that 7 is our common difference. And then our first term is -3. So if I want to go ahead and list these numbers, I know I have to start at -3. And then my common difference is 7, so I have to add 7 every time. So we have -3 plus 7, 4 plus 7, 11 plus 7, and 18 plus 7. So if I wanted to find the 8th term in this arithmetic sequence, I have f of 8, which is f of, if I plug it in, 8 minus 1 plus 7. So that is the 7th term plus 7. So the 8th term equals the 7th term plus 7. So I kind of need to add a couple more slots here. So if I continue to add 7 over and over again, I get 32 and 39. So that means that f of 7 is 39, but then I want to continue, and I get 46 as the 8th term. So I know for a fact that f of 8 is 46.